Hello everyone. Today we are going to learn the new topic, that is the Sonet. Sonet means synchronous optical network. Otherwise we are also calling SDH, that is the synchronous digital hierarchy. Synchronous optical network, we will see the stepwise, that is the what is the actual Sonet and SDH. We see the details. Sonet. In this today's lecture, we are introducing, that is the wide area network, that is the WAN, and Sonet, that is the used as an transport network to carry loads from other WANs. We first discuss Sonet as a protocol, and we then show how Sonet networks can be constructed from the standard defined in the protocol. The high bandwidth of fiber optic cable are suitable for today's high data rate technology, such as video conferencing, as well as carrying large number of lower rate technologies at the same time. For this reason, importance of fiber optics grows in some, as well as development of technologies, as well as requiring high data rate or wide bandwidth for transmission. The United States, that is the ANSI, and Europe, ITUT, have responded by defining standards through independent are fundamentally similar and ultimately compatible. The ANSI standard is called the synchronous optical network, that is the SONET, and the ITUT standard is called as the SDH. That is the Sonet will becomes under the ANSI standard, and ITT under the comes the SDH, that is the United States and Europe standardization. Sonet was developed in ANSI and same SDH was developed by ITT. Sonet and SDH is a synchronous network using synchronous TDM multiplexing, time division multiplexing. In these, all clocks in this system are locked as a master lock. Signals in Sonet, it requires the electrical signaling levels, that is called as synchronous transport signals, that is the STS, synchronous transport signal, that is the STS level, that is also STS1 to STS1922, that is the levels, synchronous transport levels signals, and it supports certain data rate specified in megabits per second, that will be given in details in tabular form. I will show here that details will be given here, that synchronous transport signals, it works up to the STS1 to STS192 levels. That STS1 to STS192, that will be given here, and that STM means synchronous transport model is initiated to compatible with existing European standard such as E-lines with the STS levels. To this end, lowest STM level, that is the STM1, defined as the 155 to 520 Mbps. First, the lowest level in the hierarchy has a data rate, that is the 51.84. that will be mentioned here Mbps, which is greater than the 44.730 Mbps, that is the DS3 service. In fact, the STS1 synchronous transport signal, they are designed to accommodate data rates equivalent to those of the DS3. This is an difference in capacity is provided to handle the overhead needs. The STS3 second one, that STS3 rate is exactly 3 times of STS1, that is 3 times increasing, and STS9 rate is exactly one half the STS18 rate. The relationship means that STS1 channel here can be multiplexed into the STS18, that STS3 channel multiplexed into STS18, and so on. That is the actual architecture and signals from STS1 to STS192. The rates, the Mbps speed users, that will be given in Sonet rates. Here will be given Sonet devices. That is the Sonet devices. Sonet transmission relies on three basic devices, that is the STS multiplexer, demultiplexer, regenerators, add a drop multiplexer, and terminals. We'll see the first one, what is the actual Sonet, what is the actual structure of Sonet, that is Sonet devices, Sonet frame, the transmission of frames, synchronous transport signal, STS1, virtual tributaries, higher data, higher rate services, that is the mentioned here. Sonet is synchronous time division multiplexing system controlled by the master clock. Here is the given, that is the STS, but that is the three basic devices, that is Sonet transmission, that is the STS multiplexer, that is the given here, STS multiplexer, STS demultiplexers, regenerators, add drop multiplexer, and the terminals, the connecting terminals. The first one we see the STS multiplexer and demultiplexer. STS multiplexer and demultiplexer mark the beginning points and end points of Sonet. Mark the beginning point and end points of Sonet. They provide the interface between an electrical network and the optical network. And STS multiplexer multiplexes signals from multiple electrical sources and creates the corresponding optical cable signal. And STS demultiplexer demultiplexes an optical signal into corresponding electrical signals. What is the role of regenerator? Regenerators extend the length of the links. Regenerator is a repeater that takes received optical signals and it demodulates that signal into some corresponding electrical signals, STSN, and regenerates and finally modulates the electrical signal. Here is the given ADM, means that is the add drop multiplexer. STS mux means synchronous transport signal multiplexer. STS demux, that is the synchronous transport signal demultiplexer. R is the regenerated and T is the terminal. In this signal into the corresponding optical cable, Sonet regenerated replaces some of the existing overhead information, that is the header information, with new data, otherwise new informations. Another one important part of the STS mux demux the regenerator. After that we are moving toward the add drop multiplexer. Add drop multiplexer allows insertion of and extraction of signals. That is, the ADM can add STS coming from the different sources. Here is the coming from the different sources into given path, or can remove desired signal from path and redirect it without demultiplexing the entire signal. Add drop multiplexer use header information such as addresses and pointers. In this simple configuration, the number of incoming electronic signals are fed into STS multiplexer where they are combined in signal optical signals. That is, the optical signal is transmitted to again regenerated, where it is recreated without the noise and it has picked up into the transmit, and that regenerated signals from number of sources fed into the add drop multiplexer. The add drop multiplexer recognize these signals if necessary, then it will be sent to the information to the data frames. The terminal is a device that uses the services of Sonet network. For example, in the internet terminal can be router that needs to send packets to another router at the other side of Sonet network. Connections. The device defined in the connections are, that is, the line, paths, sections. So section is the optical link connecting two neighbor devices, that is the multiplexer to regenerator, or regenerator to regenerator, that is the called as section. Lines, the line is the position of network between two multiplexer, that is the STS multiplexer to ADM multiplexer. This is the connecting lines. Path, a path is end-to-end portion of the network between two STS multiplexers in a simple Sonet of two STS multiplexers. Then we move toward the frame format. STS is composed of 8,000 frames. Each frame is two-dimensional matrix of bytes with 9 rows. Here is the mentioned 9 rows by 90 octets per row, means that is the columns. The STS frame is 9 row and 90 columns, means 810 bytes, and STS3 is 9 rows by 270 columns, that is the 2430 bytes. The frame and byte and bit information. The Sonet frame is matrix 9 rows and 90 bytes octets, that is the total 810 bytes. The first 3 columns of the frame, that are used as section and line overhead, that is called as administrative overhead. The upper three rows of the first three columns, are used as section overhead, that is the SOH. The lower six line overhead, that is called as LOH. The test of the frame is called as the synchronous payload envelope, that is the SPE. It contains user data and path over the overhead, that is the POH, needed at the user data level. We will discuss the format of SPE. The section overhead, it contains the 9 octets, that is the 90 octets per row, and that is the 3 transmission overhead. Remaining 87 to 9, that is 783 octets. The user data, that is the 86 into 9, that is 774 octets. That already we seen the Sonet rates for the say, STS1 to STS192 as per the different data rates. Here is mentioned the frame format. Frame 1 to frame 2 up to the frame 8000 frames per second data rate. There are 3 parts: raw rate, SPA rate, and user rate. That 8000 frames per second into rows and columns into 8, that is almost 51 lakh 84,000, almost 5 crore 18 lakhs 40,000 EPS. SPA rate, it will be that will be connected here 87 for the SP and user data is the 86, that is the given 87 into 8, that will be the change of in the 5 crores. User rate, here is the taken 86 into 8. VT types, that is the VT 1.5, VT 2, VT 3 and VT 6, that is the 8000 frames into here 3 columns and 9 rows are different 9 rows, and that is the total 8 bits, means we get the 1.72 Mbps. In VT2 same, that is the 4 columns and 9 rows, that is the 2.304 Mbps. In VT3, that is the 9 rows, that is the 8 bits, there is the 6 columns, that is the 3.4 Mbps. In VT6, 8000 frames into 12 columns, the 9 rows, that is the 6.912 Mbps. Means what will be the change in VT 1.5, VT 2, VT 3 and VT 6? That is the in VT 1.5 to VT 6, the speed of data rate will be changes from 1.7 to 6.9 Mbps. And also in different VT types, there is the columns will be different. That is the first one 3 columns in VT 1.5. In VT 2, there is the 4 columns. In VT3, 6 columns, and VT6, there is the 12 columns, and the data rate will be increasing. It is the simple STS multiplexing from transport signal, that is the they are connected STS1, STS1, and the inputs will be given to the multiplexer. It will be mixes all the signals which generates the STS3. This is the all about the Sonet and SDH. That is the actual United States channel and European channel. That is the ITVT and ANSI channel. That is the synchronous digital hierarchy. I think we will clear the Sonet and SDH. Stop here.